to mole and mass calculations and atomicity, molar mass, calculating number of atoms in a compound, and so on. So first, let's begin. What is the definition of molar mass? So molar mass is the mass of the atom in a 1 mole of a substance. That's why we call it molar mass. And the mass is always in gram for 1 mole of a substance. So the answer in this question is the mass of 1 mole, B. Moving on. What does the atomicity refer to? And atomicity is very important because we need it in calculating how many atoms in a compound I have. So I need to know the atomicity. It refers to how much of that atom I have in a compound. So H2O, I have 2 atoms of hydrogen and 1 atoms of O. So atomicity equal here 3. So the number of atoms in a compound, in a molecule. So it is choice B. Calculate the molar mass of H2. That's a standard general question. In order to calculate the molar mass, you always need to use the periodic table. And I remind you that in the periodic table, I have 2 numbers. Sometimes the molar mass is written on top, sometimes it's written below. It depends. You always take the higher number because the lower number is going to be the number of electrons. We're done with it in term 1. So the molar mass of H2O is equal to the molar mass of hydrogen twice plus the molar mass of oxygen. So that is 2 times 1 and 16. I got these numbers from the periodic table. That is equal to 18. Never write an answer without a unit. That's very important. Gram per mole. Next, the molar mass has a unit of. You might get questions like that. So be careful to the unit. It's It's not liter, it has nothing to do with the volume. It's the mass in a mole of a compound, not a mole of a compound in a mass. So it's B. Now, here comes several questions on calculating the molar mass. Now, a question like molar mass could be made difficult if the compound given is yeah, if the compound given is complicated. The first one is simple. I have 2 N atoms in it, N and N. I have 4 hydrogen atoms in it, and I have 3 oxygen atoms. So we need the periodic table. In the periodic table, nitrogen molar mass is 14, so that is 14 times 2. And the molar mass of hydrogen is 1, so that is 1 times 4. And the molar mass of oxygen is 16 times 3. So the molar mass is the sum of all of these. So 14 times 2, that's a 28, plus 4, plus 32, 48. 16 by 3, that's a 48. And when we add 28 and 4 and 48, the answer is 80 gram per mole. Now, here is a more complicated formula. What is the molar mass of magnesium hydroxide? If this is complicated to you, learn to split it. Mg, obviously there is one, but OH is given twice. It means I have OH twice, like that. So the molar mass in the periodic table, magnesium is 24, and I have 2 oxygen atoms, that is going to be 16 times 2, plus, be careful not to multiply, to add, and I have 2 hydrogen atoms, and the molar mass is 1. So the final answer is 58 gram per mole. Now again, another formula, but it's not that complicated. It is Na3PO4. I have 3 Na and I have 1 P and 4 oxygen. So the molar mass is going to be the molar mass of sodium by 3 added to the molar mass of phosphorus added to the molar mass of oxygen 4 times. So when we do our calculations, we find that the molar mass is 164 gram per mole. Moving on to the next question. Again, no, now this is atomicity. They are asking us to find the atomicity in this compound. Again, some compounds, they look complicated, like these two are complicated, whereas this one is simple, straightforward. Always learn to split the formula, to distribute the formula. So here I have one barium and I have OH in the parentheses twice. It means I have one, two, three, four, and five atoms in this compound. I have five atoms. And to be more specific, I have one atomicity for barium ion and two atomicity for hydroxide ions. Next, ammonium carbonate. Again, I have NH4 twice because there's two written over here, and I have CO3. So what is the total atomicity? We have two nitrogen atoms, we have eight hydrogen atoms, we have one carbon and three oxygens. So that is 14. Now, if they are asking us about the atomicity of ions in this ionic compound, that's how you do it. So I have here NH4 plus ion twice, balanced by 1 CO3 2 minus. Of course, I need this twice to balance this 2 minus. So therefore, atomicity of NH4 plus is 2. Atomicity of carbonate ion is 1. Again, another simple formula of a compound. The atomicity, I have 1 Na, 1 hydrogen, 1 sulfur, and 4 oxygen. So that is 7. And if they ask about the atomicity of ions, here I have an A positive ion versus HSO4 1 minus. So 1 to 1. One atomicity for sodium ion and one atomicity for hydrogen sulfate ion. Don't worry a lot about the atomicity of ions. It is usually indicated in the question, the ion itself. So you know that you're going to split Na from the rest. Or you have to split here CO3 from the rest. So it comes in the question, the formula. Now moving on, starting with Avogadro's number. Avogadro's number is a number used to calculate the representative particles. And I mean by representative particles to calculate ions in monoatomic ions or ions in a compound. Also, Avogadro's number, I can use it to count atoms or atoms in a compound and molecules and so on. So in our lesson, we are mainly focusing on using Avogadro to count atoms in a compound or ions in a compound. That's why I introduced atomicity. So In every 1 mole, there's always 6.022 times 10 to the power 23 particles, and those particles could be atoms, ions, compounds, like I mean molecule, or formula unit. But we are going to focus on atoms in a molecule. That's the main focus in the following solved questions. So here we start. How many moles of atom, moles of oxygen atom I have in a given number of atoms? I'm going to give you the formula. The number of oxygen atoms is equal to mole times Avogadro times atomicity. Now, if we are going to calculate how many mole of oxygen atom, then there is no need for Avogadro's number. So in a compound, it's just the mole times atomicity. Now, here they want to know the number of atoms of oxygen, how many moles of atom of oxygen. That's a very simple formula. I have how many oxygen atoms. I only need to find out their mole. I can also write the formula in a simple way. The number of atoms over Avogadro's number. Okay? So, number of O in O atoms. Or if I used what I was giving you, number of oxygen atoms equal mole times Avogadro times the atomicity. Here, atomicity is 1. So I simply need to divide this number or substitute it over here divided by Avogadro, and that is 2 moles. With more practice, you will get used to this formula. How many atoms are there in 0.25 mole of N2? So, how many atoms in a compound? How many atoms in a compound? So, mole times Avogadro times the atomicity. So, 0.25 is the mole. It is N. That is N. So, the number of atoms that we are calculating here is 0.25 multiplied by Avogadro's number multiplied by atomicity. And here in this compound, we have 2 nitrogen atoms. So that is times 2. So the answer is um, here we have, I'll just calculate it, 0.25 times 6 times 2. So the answer is 3 times 10 to the power 23 atoms of nitrogen. Now, how many moles of magnesium are in this much of magnesium atoms? Magnesium atom in magnesium atoms, atomicity is 1. So whenever I have this number, I can just calculate how many moles of magnesium they are. I have the number of atoms. They want N. They want how many mole? Atomicity here is 1. We are looking at how many atoms of magnesium, how many moles of magnesium. So I have 4 equals the mole to calculate times Avogadro's number, and the atomicity is 1. Or simply think about it using this formula. Mole is the given particles over Avogadro. So it is 2.4 times 10 to the power 24 over Avogadro's number. And that is 4 moles. So this is, we say, this is how we convert particles to mole. Whenever we have a certain amount of particles and we want to find it in mole, we always divide by Avogadro's number. And the number of particles is like a complicated number. It's a large number. Now, let's look at another question. 3 moles of a sample of NH3. How many hydrogen atoms it contains? So how many hydrogen atoms it contains? We are only focusing on hydrogen. I'll write the formula again. So the number of hydrogen atoms, the number of atoms is equal to the given number of mole multiplied by Avogadro's number multiplied by atomicity. Since in this question they are only concerned about hydrogen atom, so atomicity here is 3. So 3.0, the number of mole, multiplied by Avogadro's number, multiplied by hydrogen atomicity. And the answer is C. Again, what is the number of oxygen atoms? It's the same formula. Number of atoms of oxygen. This time I have it in 2 moles. So here, 2 moles. We always multiply by Avogadro. Now, the formula says times atomicity. Now, what do they want? They want only the atoms of O in this compound. So the atomicity over here is 5. And the answer is B. So be careful whenever they ask number of atoms in a compound. Number of atoms in a compound. Atoms in a compound. So the other one was atom in an atom. I still use the same formula, but I used atomicity to be 1. Here, atoms in a compound, atomicity 2. So I'm always using the same formula whenever I want to calculate number of atoms. Now, again, number of hydrogen atoms. So number of atoms of hydrogen is equal to the number of moles multiplied by Avogadro's number multiplied by the atomicity of hydrogen in this compound. So 4.20 mole times Avogadro times 4 because they only want hydrogen. They're not interested in nitrogen. So if they said nitrogen, I would multiply by 2. If they said atoms in general, I will multiply by the total atomicity, which is 6. Moving on, what's the number of oxygen atoms in 3 moles of this? Again, 3 by Avogadro's number by the atomicity of oxygen. And I have here 2 atoms of oxygen, so the answer is B. Now, molecules are getting complicated. Hydrogen atoms, how many hydrogen atoms in 1.2 moles? So 1.2 again by Avogadro's number by atomicity. Now let's look at it. How many hydrogen atoms in this? This has 2 NH4 and 1 SO4. It means that I have 8 hydrogens in one molecule, or you simply multiply 4 by 2. So the atomicity of hydrogen over here is 8. Next, atomicity, what is the number of carbon atoms? Again, we look at the given mole by Avogadro's number by how much carbon atoms. I have 6 over here and 1 over here. That is 7. So the answer is So I think you're getting the concept of this one. Number of nitrogen atom in zero point 0.5 moles of nitrogen trioxide. Only nitrogen, so it is 2. Answer is B. Moving on. Again, how many atoms in 2 moles? Look at He. Atomicity is just 1. How many atoms? So the atom is 2 times Avogadro times 1. So that is D. Sorry. Now, number of moles in ions. Number of moles in ions. I have the number of ions, a very complicated number, U divided by Avogadro. So we want the number of moles. Or if I apply this formula, number of ions equal to mole, which they wanted here, times Avogadro times atomicity. I only have one. So it is given 2.4 times 10 to the power 24, and they want n, and I have Avogadro's number. So I'm dividing this by Avogadro's number, and that is 2. Sorry, 4. A. Now, moving on. In the chemical formula of H12O6, what does the subscript 6 for carbon indicate? This is the atomicity of carbon. It is showing me how many carbon atoms I have in one molecule. It's not in 1 gram. It has nothing to do with the mass. And be careful, it's the atomicity of carbon, not the compound. So the answer is B. Here's an ionic compound. They want the ratio, they want the atomicity of every ion. And in this one, I have 1 to 2. I have 1 calcium with 2 Cl minus. So the ratio is 1 to 2. In the chemical formula, Al2O3, what does the subscript indicate? It shows the number of oxygen atoms. Actually, it should be oxygen ions, but I don't have any option for oxygen ions, so I'm going to go with B. Next, another subscript in the formula, what does it indicate? Indicates how many sodium and A I have in this compound. So it is A. What happens if no subscript is written next to an element in a chemical formula? Like, for example, in here, there is no subscript written next to P. It means that I have only one of this formula. So one atom of that element in the formula. So it is A. Now, other type of calculations, how many mole of atom? Mole of atom. The question didn't say how many atoms. Previously, we were calculating how many atoms in mole. Now, how many mole of atoms in a mole of a compound? And here in these questions, you calculate the mole of atoms, mole of atom by taking the given mole by atomicity. We do not introduce Avogadro to the formula. So it is 2 times. We're talking about O. Atomicity of O is 1. So I have in 2 moles of water, I have 2 moles of oxygen. Another question. A sample contains 3 moles of carbon dioxide. How many mole of oxygen? Mole of O atoms. They didn't say how many atoms of O. They said mole of atoms. So in the formula, mole of atom, we do not use Avogadro. So just by the atomicity. And that is 3 multiplied by atomicity of O. 6 mole. Again, how many mole, if you have 4 mole of ammonia, how many mole of hydrogen atoms? We are interested in H, so it is 4 times atomicity of H. So I think you're getting the point of this one. Be careful when you are reading the question. If it says how many atoms or how many moles of atoms. So here, 5 mole of methane, how many mole of hydrogen? So 5 times atomicity of hydrogen. So 5 times 4. Okay, so now how many moles of nitrogen? So again, 2.5 times the nitrogen, that is 5. Now let's move on to the problem solving. A student has 1.5 mole sulfuric acid, that is N. Calculate the number of moles of hydrogen and sulfur and oxygen atom in the sample. That's very easy. Let's split it. Mole of hydrogen that they want, mole of sulfur that they want, and mole of oxygen that they are asking for. They are asking mole of atom. So no need for Avogadro's number. I only going to multiply the given mole by atomicity. Atomicity of H is 2. So 3 moles of hydrogen. Atomicity of S is 1. So 1.5 mole of sulfur. Atomicity of O is 4. That is 6 mole of oxygen. Moving on. How many mole of atoms are in 2 mole of aluminium sulfate? So here they're making how many mole of atom? I have aluminium, I have sulfur, and I have oxygen. Mole of atom. So in each one, I'm going to multiply the given mole by atomicity. By atomicity. So how many aluminium? I have 2 aluminium. So it is 2 times 2, 2 times 2, 4 moles of aluminium. Now for S, let me split this. Al2SO4 means I have 2Al and SO4 3 times. So what is the atomicity of S? I have 3 S atoms and I have 12 atoms of oxygen. So for S, we're going to multiply the given mole by 3, whereas for O, we're going to multiply the given mole by 12. So that is 24 mole oxygen and that is 6 mole of sulfur. Again, how many mole? A chemist has 0.75 mole of glucose. How many mole of carbon, of hydrogen, and oxygen atom? So I take this 0.75 and I multiply it by atomicity. So for carbon, it is 6. Same thing for oxygen. It is times 6. Now for hydrogen, it is times atomicity of hydrogen, and that is 12. So 9 mole of hydrogen, and for this one, each one is 4.5 mole.
Miss,
Next, yes,
for question two, why did we not do 17 times 2?
17,
Yes,
12.
no, يعني why did we not add all the compound and this times by 2? Why did we break it down?
Ah, wait, I can then add them all. Yeah, I didn't finish that question. So, yeah, you're right. Because the question says how many moles of atoms in total. Yeah, I can say 4 plus 6 plus 24. Yeah, and I can, if you want, simply say the given mole multiplied by the total atomicity. The total atomicity is 2 aluminum plus 3 plus 12. Yeah, you're right, 17. So here I'm going to get the same number, 34 mole. And if I add 4 and 6 and 24, that is also 34 mole. Okay? Next, how many mole of ions are found in 2 moles of NaCl? How many moles of ions? I have uh, I have one. The atomicity here is 1 plus 1. The atomicity here is 2. So 2, because one Na plus and one Cl minus. So 2 times atomicity. Clear? Again, a solution contains 2.5 moles of aluminum sulfate. How many moles of ions does it produce? Okay. Now here they didn't say how many moles of atoms. They didn't say atoms to count 2 and 3s and 12o. They only want the ions. And by looking at this one, I have 2 positive ions versus 3 negative ions. Let me just explain it better. I have 2 aluminum 3 plus versus 3SO4 2 minus. When you work the charges, you will understand the formula. 3 plus twice, that's a 6 plus, versus 6 minus. So the atomicity of ions in here is 2 ions and 3 negative ions. So atomicity is 5. So here I have 2.5 times 5 ions. It is D. Again, how many mole of ions? In this one, I have K plus twice, and I have 1SO4. When you work out the charges, it will be logic. So I have 2 for positive ions and 1 for negative ions. Atomicity of K is 2, atomicity of SO4 2 minus is 1. So the total atomicity is 3, 4 times atomicity. Now, a chemist dissolves 2.8 mole of sodium sulfate. They want the total number of moles of ions. If they said atom, I would say 2 plus 1 plus 4. But they said ions. It means I have Na plus twice versus 1SO4 2 minus. So the atomicity is 3. So the total number of moles of ions is 2.8 times 3 ions. That is 8.4 mole. Moving on. Determine the number of moles of ion in 5 moles barium chloride. Ions, mole of ions. It didn't say mole of atoms. So here I have 1 barium ion and 2 Cl minus. So the atomicity is 3. So 15 moles of ions. Is this part clear? Now, how many moles of ammonium phosphate? No, a student has 4.2 mole of ammonium phosphate. Calculate the number of ions. Let's look at this one. I have, the question doesn't say mole of atom, it says mole of ions. I have 3 times NH4 plus versus 1 PO4 3 minus. Look at the charges. We need 3 pluses to neutralize this 3 minus. So here I have a total of 4 ions. Atomicity is 4. So 4 times 2, 4.2 times 16.4. That is 16.8 mole of ions. Now, moving on to a different kind of questions. Mass in mole and mole in mass. This is the formula that we are going to use. Mass in gram, molar mass in gram per mole, and N in mole. In these questions, these are always two-step questions. You have to find the molar mass. In the previous question, we calculated the molar mass of H2O to be 18. So 1.5 mole equal the mass over 18. So the answer is 1.5 times 18, 27 grams. Again, what is the mass of 2 moles and ACl? 2.5 mole equal the mass over the molar mass. Here in this question, they gave us the molar mass. So they saved the time. Instead of asking us to calculate the molar mass, it's given. So 58.44. And that is 146.1 gram. Again, how many mole in 5.6 grams? Mole in. Oh, sorry, this is opposite. So now we need to find mole. We have the gram. I still need the molar mass. So from the periodic table, calcium is 40 and oxygen is 16. So 40 plus 16, that's a 56. So I have a 0.10 mole. Again, what is the mass of 3 moles? Mass of 3 moles. 3 moles. Here's the mass. I need from the periodic table, I find hydrogen to be 1, but I have it twice, plus 32, the molar mass of sulfur. That is 34 gram per mole molar mass. So the answer is 102 grams. How many molecules? Okay, that's a challenging question. They didn't ask how many atoms. So mole is equal to the number of particles over Avogadro's number. And here the particles, we are talking about molecules. So forget about atomicity. Now, I don't have mole. The question is not giving me mole yet. The question is giving me mass. But I do know that if I divided the mass by the molar mass of water, I am going to get this N. So I'll divide this 9 by 18 to get the mole. And then this is going to be 0.5 something. So 0.499, that's a 0.5. I'm going to put 0.499 equal the number of particles and Avogadro's number. So you multiply it and you get that you have 9.3 times 10 to the power 23. You have 3.11, 23 molecules. Now look at the comparison of these two questions. So as I said, the question said how many molecules, no atomicity in the formula. But if the question asks how many atoms, again in 90 gram, here, after finding this number of molecules, you have to add atomicity. So you divide the mass by the molar mass, You get the mole, you multiply the mole by Avogadro's number by atomicity. And atomicity here is 3. So I'm going to take this answer and multiply it by 3. So I'm going to get 9 point times 10 to the power 23 atoms H and O. I calculated both. Now, moving on, atoms of neon. What is the mass? Okay, this is a two-step. I have atoms and I need the mass. So first, I find the mole of neon atoms. I find the mole of neon atoms, and then whatever answer I get, so 3 times 10 to the power 23 over 6 times 10 to the power 23, that's a 0.5 mole. Now I need to plug this into the formula of mass over molar mass. So 0.5 mole equal the mass that they want over the molar mass of neon. From the periodic table, the mass of neon is 20 grams per mole. So I'm going to multiply this by 20. Again, here calculate the number of carbon atoms in 18 grams of glucose. This is a difficult question because it involves many steps. So let's put a map to solve this question. I can't find the number of atoms in mass. I need it in mole. So I need to change this gram into mole, then use the mole to find the atom. So first I'm going to use the formula of mass over molar mass. I'm going to divide this 18 over the molar mass of glucose. Now let's find the molar mass of this one. It is 6 times the mass of carbon. From periodic table I got the 12 plus 12 times the hydrogen. Hydrogen is 1. And 6 times the oxygen. So solving this will get 180 gram per mole. So I'm going to divide 18 over 180 and that is 0.1 mole. Now, calculate the number of carbon atoms. Number of C atoms is the mole times Avogadro times atomicity of just carbon. So there's 0.1 by Avogadro times 6 atomicity of carbon. The final answer is 3.6 times 10 to the power 23 atoms. Moving on, calculate the number of moles of sand in 6.4 gram of sand. Again, whenever you see mass in a question, immediately look for the molar mass. Okay, so in order to find the mole, I need to divide the mass by molar mass. Now, from the periodic table, silicon mass is silicon, I think is 28, the molar mass of silicon. Let me just double check. So silicon is, yep, true, it is 28. And oxygen is 32. So 28 plus 16 by 2, that's a 32. So 28 plus 32, that's 60 grams per mole. So the mole is 6.40 over 60. So 6.4 over 60 is a 0.107 mole. I have a mistake in the answer key, I think, because I used the molar mass of SiO2 wrong. So the correct molar mass is 60. Now, calculate the number of silicon atom in this 6.4 gram. Alas, no need here. We just converted this gram to mole. So as if they are telling me, calculate the number of moles of atoms in this mole. So this one times Avogadro times atomicity of silicon. Atomicity of silicon is 1. So almost the same answer, 6.4 times 10 to the power 22 atoms silicon. And calculate the number of oxygen atoms in the same 6.4 gram, which is 0.107 mole. I'm going to take the mole by Avogadro by the atomicity of oxygen, and that is 2. So times 2, the answer is 1.28 times atoms of oxygen. I'm moving on faster because I have another session that starts in 10 minutes. Stoichiometry. So these are just simple questions of stoichiometry. What is stoichiometry? Stoichiometry will tell you the quantities that are needed or the quantities that we will obtain in a chemical reaction. So it involves the calculations of reactants and products in a chemical reaction. Which of the following is an example of a stoichiometric analysis? Definitely not related to measuring temperature, not the pH of acidic or color or whatever. It just talks about quantities. Quantities. Next, explain the importance of the law of conservation of mass. Be careful to this definition. The law of conservation of mass. Conservation means mass is saved. It's the same. So the mass of reactants should and always be equal to the mass of the products. Next, mole ratio in a chemical reaction. From where are they derived? So if I have a chemical reaction, I can derive the mole ratio from the stoichiometric coefficients. So from these numbers written, if there is no number, it means it's a 1. So here I have, for example, if I want to write the mole ratio of A to B, it's 2 over 1. Okay, so these numbers, we derive them from the stoichiometric coefficients in a chemical equation. What is the mole ratio of nitrogen to hydrogen? Read the sentence. They said N2 to H2. So 1 to 3. 1 to 3. If the question was of H2 to N2, then your answer would be 3 to 1. So now the correct answer is C. Why mole ratio must be derived from a balanced chemical equation rather than the number of atoms in it? Yes, of course, because we cannot count atoms. It's the mole. When an equation is balanced, we balance it by counting the atoms on it, and we add stoichiometric coefficients. So in order to balance mass and everything, we need to count um, we need to take into consideration those stoichiometric coefficients. If an equation is written without those stoichiometric coefficients, I mean the 2, the 1, the 3. If it's written without those coefficients, then it is not balanced. It's wrong. Moving on. What is the first step in converting a word equation into a balanced equation? Well, you need to know the name and the formula of these reactants and products. Yeah, the word equation, we don't need to write the balancing. We don't need to write the numbers of the coefficients. Now, which of the following is a balanced chemical equation? Let's count. 2 hydrogens here, two hydrogen. Hydrogen is balanced. 2O versus 1O, not balanced. Well, look at this one. It is balanced. Next, write a balanced chemical equation for the following word equation. When you read the word equation, be careful to the way they are wording it. So calcium carbide, CaC2, reacts with to produce. So it is CaC2 reacting with H2O to produce. That's the arrow. To produce. To produce what? Acetylene gas, C2H2, and and CaOH2. Here, it's the unbalanced equation. Now let's balance it. So I'm going to split this equation into two and I'll start counting. I have calcium, carbon, hydrogen, and oxygen atoms. Calcium, carbon, hydrogen, and oxygen atom. Let's count. One calcium, one calcium. Two carbon, two carbon atoms. Two hydrogens, and here I have two from here and two from here. Separate them because they are already in separated formulas. And I have one oxygen, and in here, this is CaOH twice. It means I have two oxygen. The number that it is not equal is the number of oxygen and hydrogen. So I'm going to start with the easy one, and I'm going to multiply this by 2. By multiplying this by 2, I don't have any more 2 hydrogens, I have 4. And now it is balanced. So that's it. This is the balanced equation. Determine the mole ratio of. Okay, after doing the balancing, so I'm going to erase this so that I can have a clear space for these questions. So I'm going to write this again, CaC2 plus 2H2O. So here is was the unbalanced and down the balanced. So the ratio of this to this, 1 to 2. Now CaC2 to C2H2, 1 to 1. CaC2 to CaOH2, 1 to 1. Now one more question, H2O to C2H2, 1. Here are the mole ratios. Next, interpret the following chemical equation. Just a second. I'm just going to send an email to my next students because I have another remedial session. I'll let them wait for like 10 minutes and then I start the, and by the time, I just need 10 minutes to finish here. So just a pause. MG, and second, I'm sorry for this. Okay, so let's continue. Interpret. Um, Interpret the following balanced equation in terms of moles and mass. So, in terms of moles, you just have to read the moles on the equation. I have 1 mole of K2S with 1 mole reacts with 1 mole of COCl2 to produce 2 moles of KCl and 1 mole of COS. And when they say in terms of mass, I just want to show you this formula. Mole equal mass over molar mass. They want it in terms of mass. And in order to calculate mass, we multiply the mole by the molar mass. So here, the molar mass of potassium sulfide is 39 times 2, because I have 2 potassium, plus sulfur, that is 32 grams. It is 110 gram per mole. So I'll multiply this 110 by 1. So I'll say 110 grams of K2S reacts with, again, the cobalt, the cobalt molar mass is 59. So 59 plus 35.5 times 2, that is 130 grams. And I'm going to multiply this 130 by 1, because to find mass, we multiply it by the molar mass. So 130 grams of COCl2 to produce, again, KCl 39 plus 35.5, that is 74.5, but I need to multiply it by the given mole. So the final answer, it produces 149 grams of KCl, and, and I calculate the molar mass of cobalt, 59 plus sulfur plus 32, that's 91 grams of COS. Again, another equation, I need to interpret it in terms of moles, mass, particle. So in terms of moles, I have 2 moles, 2 moles, 1 mole. In terms of mass, again, mass is mole multiplied by molar mass. The molar mass of water is 18, so I'm going to multiply 2 by 18, that's 36 grams. The molar mass of hydrogen is 2. I'm going to multiply 2 by the mole. That's a 4 gram. And the molar mass of oxygen is 32. I'm going to multiply it by the mole. In terms of particle, when you want to calculate the particles, you will multiply the mole by Avogadro. So again, this mole, I'm going to multiply it by Avogadro. 2 times 6 times 10 to the power 23, 2 times 6 times 10 to the power 23, and 1 times 6 times 10 to the power of 23. Here we say atoms, molecules of O, all of it we say molecules of O, and this is 12 times 10 to the power 23 molecules of hydrogen, and also here 12 times 10 to the power 23 molecules of hydrogen. Now, continuing, almost there, the mole ratios. Okay, I'm gonna copy again. Oh, here, wait, there's a question. How many mole ratios can be written for the above equation? When we have an equation, there's a formula of n multiplied by n minus 1. We use this formula in order to know how many mole ratio can we write. So I count here 4 substances. So I'm going to say 4 times 4 minus 1. So that is 4 times 3, 12 possible mole ratios. Now I'm going to copy this equation again here to answer these questions easily. So I have here mole ratio of CH4 to H2O 1 to 2, O2 to CO2 2 to 1, H2O to CO2 2 to 1, CH4 to O2 1 to 2. Now, last two questions. Write the balanced chemical equation and word equation for the bill. So, when you are reading this, be careful to highlight the formulas in order to write them in the balanced chemical equation and to highlight the names so that you can write them in the word equation. So, let me start with the names. So, a sample of tetraphosphorus reacts with oxygen to produce tetraphosphorus hexaoxide. So, tetraphosphorus reacts with oxygen to produce tetraphosphorus hexaoxide. That's the word equation. Now, for the chemical equation, I have P4 reacting with oxygen to produce P4O6, and it has to be balanced. So P4 plus O2 gives P4O6. Now let's count. I have 4P and 2O. I have 4P and 6O. All I need to do is multiply this by 3, and I'll get a balanced equation. How many mole ratios can we write? Since we have 1, 2, 3 substances, then we can apply the formula. 6 possible mole ratios we can write. Again, 2 more questions. Aluminium oxide decomposes to aluminium and oxygen. Aluminium oxide decomposes to aluminium and oxygen. We need it balanced. So here I have 2Al and 3O, 1Al and 2O. So I'm going to multiply this by 3 and this by 2. So here's 2 and here's 3. But the number of aluminium changed to 4, so I'm going to multiply this by 4. That's the balanced equation. For the word equation, it is aluminum oxide decomposes to aluminum and oxygen. So oxide into aluminum and oxygen. How many mole ratios we have? We can get 6 mole ratios. Now I missed this question, gives 3 possible mole ratios. I'm just going to write 3. 2 mole of Al2O3 over 4 mole of Al. Now I'm going to reverse it. 4 mole of Al over 2 mole of Al2O3. And I'm going to write 4 mole Al over 3 mole of O2. For the previous question, I'm going to write 1 mole of P4 over 3 mole of O2. I'm going to reverse 3 mole of O2 over 1 mole of P4. I'm just reading the numbers from here. And let's say 3 mole of O2 over 1 mole of P4O6. And that's it. Finally, the last question. Zirconium and iodine are obtained from the decomposition of zirconium 4 iodide. So the zirconium 4 iodide decomposes into zirconium and iodine. I need to balance it. As a word equation, zirconium 4 iodide gives zirconium and iodine. How many mole ratios? Again, same formula, 6 mole ratios. Now give 3 possible mole ratios. I'm gonna say 2 moles of I2 with 1 mole of ZR, 1 mole of ZrI4 with 1 mole of ZR, and 1 mole of zirconium I4, 2 moles of I, and that's it. Thank you for listening.
Thank you, Miss.